second part of the review of this particular paper, that is P1 second variant of June 2021. Now this particular question is about AP, it's about GP. Let's get started. It says the first, second and third term of an arithmetic progression. So arithmetic progression, the first three terms are A, 3 over 2A and B respectively. And then the first, second and third term of a GP, geometric progression, are A, 18 and B plus 3 respectively. Now in an AP, the common difference is the second minus the first term, it's third minus the second term. In a GP, the common ratio is second divided by the first term, the third divided by the second term, and so on. So therefore, 3 over 2a minus a is the same thing as b minus 3 over 2a. So 3 over 2 plus 3 over 2, that is 3. So this is 2a equals to b. This is equation number 1. Over here, the common ratio, that is 18 divided by a equals to b plus 3 divided by 18. In other words, 18 square is equals to a multiplied with b plus 3. That is the second equation. Now let me solve it simultaneously. B is equals to 2a. So 18 square is equals to a multiplied with 2a plus 3. That is 2a square plus 3a minus 18 square, which I need to evaluate using a calculator. I think it's 324, something like this. So 18 into 18 is 324. Minus 324 equals to 0. And you will have values of a and b. So a is something and a is something, and that will give us corresponding values of b. So basically it's a question that is about quadratics, and at the same time that is about simultaneous equations. So basically you solve for a, you solve for b, and you get two answers. Now what else is it asking for? Find the sum of the first 20 terms of an AP. So now if they talk about sum of first 20 terms, so A came out to be something. So therefore we have, what are the first three terms? That is A, 3 over 2A and B. A, 3 over 2A and B. When you plug in the values, you will have the first term, you will have the common difference. First term is actually A, and they're asking for the sum of the 20 terms. Sum of 20 terms is 20 divided by 2, 2A plus 19D. Now let me make one thing very clear. That means that I have not yet solved. So I'm not sure whether two answers I'm getting or I'm getting only one answer. And it also says A and B are positive constants. So maybe it so happens I get one negative value, I get one positive value, so I will be rejecting this value. So in other words, I'll only get one value of A and one value of B. So that is the working for this particular part. Question number 9. What does it look like? This is volume obtained, integration, that is volume of revolution. Now first of all, look at the diagram. It says the diagram shows part of the curve with equation y square is equals to x minus 2. So the examiner could have written y is equals to square root x minus 2, and then after squaring, this is what you get. The lines x is equals to 5. So this is the line x is equals to 5. This is the line y is equals to 1. The shaded region is enclosed by the curve and the lines, and it's rotated 360 degrees about the x-axis. So the rule is volume is pi limits a to b, and whatever is the function in terms of x square dx. This is one single curve, one single line about the x-axis, but there are two actually. What are these two? First of all, this is your line and this one is your reddish curve, something like this. So that's how it's going. And let me erase this thing and let me just limit it up till here. So basically this is the region that we're going to revolve. What else do I need? I need to find this particular value because this will be my limits. So I need to find this value. How can I find this value? Solve these two equations simultaneously. Y is equals to 1. 1 square is x minus 2. Therefore, x comes out to be 3. So this value is 3. That means I need to revolve this curve. Let me focus on this. This is the curve. From here to here, all the way you are revolving it. And you are revolving this line also with respect to the x-axis. So basically, volume of the curve between the limits 3 and 5, there is pi, and the equation of the curve is root x minus 2, deliberately writing it like this. The whole thing square dx, that is pi 3 to 5 x minus 2 dx. It's already squared. Now integrate, that is x square over 2 minus 2x between the limits 0, it's 3 and 5. And don't forget this pi. And volume under the line, that is pi 3 to 5, equation is simply 1 square dx. That is pi 3 to 5 1 dx. That is pi, this is pi, and this is 1 becomes x between the limits 3 and 5. So therefore volume between the two, what is at the top? The curve. What is at the bottom? The line. So this would be volume under the curve, which naturally will be bigger, minus volume under the line, and that will be the answer for this particular part. So question number 9 is done and dusted. Too much extra space is given. Question number 10, that is a question of trigonometry. So the first part is trig identity. So there is a trig ID, and naturally the other part has to be an equation. So this is trig ID and this is a related equation. Now the question says, prove that the identity 1 plus sine, 1 minus sine, and so on, whatever that is. So let sine x be denoted by the symbol S. Let cosine x be denoted by C. So therefore, it's something with LCM and it's something with the identity. Of course, we know how to use the identity and we know the identities itself. So first of all, what should you do? First is LCM. 1 plus S, 1 minus S, minus 1 minus S, 1 plus S. In such a question, be very, very careful with the signs. What is in the numerator, what is in the denominator, what is in between, be very careful. Now, this will multiply with this. So this is 1 plus S, the whole thing square. There is a minus sign in the middle. And what else is there? This blue curve, not curve, bracket will multiply with this. This is 1 minus S, the whole thing square. That is the numerator. The denominator is 1 minus S, 1 plus S. Now the numerator, expand and simplify. So this is 1 plus 2s plus s square, minus sign, 1 minus 2s plus s square. Denominator is 1 minus s square. There is a minus in the middle. So this 1 and this 1 slashes, the squares slashes, 2s plus 2s because of the minus. That is 4s over c square. That is 4 into sine into 1 over cos into 1 over cos. Write it like this. Sine over cos is tangent. And 4 remains as it is. And the cosine at the bottom remains as cosine x, and that is what you get. So the first part is done. Question for 4 marks, straightforward. Now this thing is 4 tan x cosine x. The same thing, 4 tangent x over cosine x is 8 tangent x. Now remember this thing, a very golden rule. always take common whenever there is a possibility of taking common. So when you take common, you don't lose half of your solution. So basically 4 tangent x is equals to 8 tangent x cosine x, and 4 tangent x minus 8 tangent x cosine x equals to 0. Tangent x common, 4 common, 1 minus 2 cosine x equals to 0. In other words, 4 tangent x equals to 0. 1 minus 2 cosine x equals to 0. 4 goes away. Tangent x is sine x over cosine x equals to 0. Therefore, sine x equals to 0. Now, from the graph, we know that the graph of sine x is 0 at 0 and 180 and 360. But what is the range over here? The range is 0 se pi by 2. So 0 till pi by 2. So this is 0, this is pi, this is 2 pi. So only this one is applicable. So x is equals to 0 radians only at this point. Now if I were to divide, I would have lost this solution. So 2 cosine x equals to 1, cosine x equals to half, and 0 to pi by 2 is only the first quadrant. So this, overall it could be first and fourth, but we are only interested in the first quadrant. Cosine of alpha is half, basic angle alpha is pi by 3, therefore x is pi by 3. So the two final answers, write it separately. Don't leave the examiner confused. Therefore x is 0 radians and pi by 3 radians. These are the two possible answers. So this thing is done. Question number 11. What is this question all about? It's about a gradient function, it's about value of k, it's about equation of curve, it's about second derivative, it's about nature of stationary points. So therefore, it's a question about differentiation and about integration. It's a mix of both. First of all, your function is given dy by dx is equals to 6 bracket 3x minus 5 raised to power of 3 minus kx cube, kx square, where k is a constant. The curve has a stationary point. What does that mean? When x is 2, y prime, that means dy by dx is 0. When x is 2, y is negative 3.5. So it's time to use the first one. Dy by dx is 0, 6 remains as it is. Value of x is 2, 3 2s are 6, 6 minus 5 is 1. This is 1 cube minus k into 2 square. 6 is equals to 4k. So therefore k comes out to be 3 over 2. That is the answer for the first part. Find the equation of the curve. Integrate. Y is integral of this thing. That is 6. 3x minus 5, the whole thing cube, minus 3 over 2x square, the whole thing dx. Now when you integrate something, you get a constant of integration. How do you evaluate that constant of integration? You evaluate by plugging in the value of x and y. So let's first integrate. This is 6. This is 3x minus 5 raised to power of 4 divided by 4 divided by the coefficient of x, which is 3. And this minus remains as it is. 3 over 2 remains as it is. X cube over 3 plus a constant of integration c. So now 3 1s are, 3 2s are, 2 1s are, 2 2s are. So this is half 3x minus 5 raised to power of 4. This 3 cancels, minus half x cube plus c. So first simplify, then we will evaluate. When x is 2, y is negative 3.5. Negative 3.5, this is half, x is 2, 3 2s are 6, x minus 5 is 1 raised to power of 4, minus half into 2 cube plus c. And then when you do the evaluation, you will find the value of c, and c comes out to be, I think, negative 3.5. You can check it later. C comes out to be something. And that is the equation of the curve. Y is equals to half, bracket raised to power of 4 minus half, x cube. And this thing plus the constant of integration, whether that is positive or negative, plus this value. Next part, find the second derivative. Now dy by dx is 6 3x minus 5 whole cube. Dy by dx is 6 3x minus 5 the whole cube. And what else is there? Minus 3 over 2x square. Let me double check. K is this and k has a negative sign before that. Minus 3 over 2x square. So therefore the second derivative, 6 remains as it is, 3 comes down, 3x minus 5, power becomes 2, derivative of bracket is 3. Don't forget that. And this is minus 3 over 2 as it is, and x square becomes 2x. So 6 into 3 into 3, that is 6 9s are 54. So therefore this one is 54. And this is 3x minus 5 the whole thing square, and this becomes minus 3x, and therefore this is the constant, whatever that constant was, that derivative is 0. So this is the answer for this particular part. Now what else are they asking for? They're asking for the second derivative. That's done, and no need to open up the bracket, leave it intact. This looks beautiful. Determine the nature of the stationary point when x is equals to 2. The second derivative, d square y over dx square, that is 54. And this is 3x minus 5 is 1 square minus 3 into 2. So therefore this is 54 minus 6, which is a positive value. So since it's a positive value, this point is in fact a minimum. Now we have reached, I think this looks like the last question, because this is question number 12. So sometimes it's 11 and sometimes it's 12. So this time it's question number 12, and it's all about circular measure, a very, very detailed question that have come over here. Now let's study this diagram very, very properly. What this diagram says. The diagram shows a cross section of 7 cylindrical pipes. 1, 2, 3, 4, 5, 6, 7. These are 7 cylindrical pipes. Each of radius 20 centimeter. This is 20, this is 20, this is 20, this is 20, this is 20. Now why am I labeling everything? Because I need every single detail over here. It's held together by a thin rope which is wrapped tightly around the pipes. The centers of the 6 outer pipes are such and such. Points P and Q are situated where straight line sections of the rope meet the pipe with center A. So there is this thing PQ, and there is this thing and this thing. It's like a pizza sector. Show that angle PAQ is pi by 3. This angle is pi by 3. Now there are many ways of carrying this out. Let me read the question further. Find the length of the rope. That means I need to add this thing, that's too thick. I need to add this thing and so on, and then this thing like this, and then another one like this. So I think you're observing that there is some kind of symmetry in here. Of course there is. So there is like this. Let me get this straight. And one more portion that is like this. So there are these portions that you can see. And then there are these orange portions. This is one and this is the other one. So you don't have to draw actually all of them. It's just giving you the feel that there is symmetry over here. And then there is this one, and last but not the least, in this one. So that's how the diagrams look. Diagram looks like. Find the length of the rope. I'll be taking care of that. Find the area of the hexagon ABCDEF. Give your answer in terms of root 3. So ABCDEF, what is that? That is, let me make it more thinner. This is AB. This is FA. This is like this. Exact same scenario downstairs below this level. This and this and this. So whatever are the dimensions of green, that same dimension is that of the purple. So this, they are exactly the same. Now this FA is the same thing as, let me first label it, is the same thing as, let me get a purple color. This to this is the same thing as this to this. So this is PQ, and let me label this as R, and this is S, and this is T, and what else is this? This is U, and this is V, and this is W, and this is X, and this is Y, and this is Z, and let me choose one other letter, that is M. No, M, no, there is no M, so I can choose that. A, B, C, D, E, F, and let me call this thing as M. So you have all these labelings over here. Now, something to do with the area of hexagon, and last, find the area of the complete region. So first of all, let me draw this diagram at some other place also, or let me just remove the labelings like this. I think that is more than enough. Now first of all, let me do this whole thing together. This is 2 mark, and 4, 6, 6 and 2 is 8, 8 plus 3 is 11 mark. 11 mark question. If this is 20 and this is 20, therefore this whole thing is 40, correct? That thing is done. So this is 40. And what else is there? This is also 40, and then all these 40s are there. First of all, I have to prove something about this angle. Now, can I say that these two lines are just like this? So these two lines are parallel, and this thing is 90 degrees and this thing is 90. That's for sure. This angle over here in purple, that's the interior angle of a regular hexagon. So this is a regular hexagon. Hexagon has 6 sides, so that is 6 minus 2 into 180 degrees. Divided by 6, that is 4 over 6 of 180, that's 2/3 of 180, that is 120 degrees. So this angle is theta, that's 120. Angles at a point add up to 360, these two are already 90. Therefore, this blue angle over here and this theta, let me label this as beta. So beta plus theta should also be 180. Therefore, beta is 180 minus theta. This is theta. That comes out to be 60 degrees or pi by 3 radians. So this I have done the first part over here. So part A, that's done. That is part A. Now, once this is done, what else do I need? Now, what else do I need is that, let me remove all this color from here, or let me add a diagram. I think so I took a screenshot earlier. So yes, I have a diagram, spare diagram. And then it says find the length of the rope. Now this thing, all these blue lines are the same. So let me label this again. This is 40. There are 6 such lines. This is the second one. This is the third one. The fourth one, let me draw it properly. It's not drawn to scale, yes, for sure, but it has to be realistic. There are 4 lines like this. And there are 6 lines like this. So they all would be the same, like this and like this. It's not very much accurately drawn, but it will serve the purpose. So now this thing, let me enlarge it. This thing is pi by 3. This thing is 20. Can I find PQ? Arc length PQ is equals to r theta, that is 20 multiplied by pi by 3. So 6 multiplied by 20 into pi by 3, that is 3 ones are 3 twos are, that is 40 pi by 3. And similarly 6 multiplied by 40, that is because of the radius and the radius. This radius is 20, this radius is 20, therefore this thing is 40. So therefore this is 6 multiplied by 40, that is 240. It does not say exact, it does not say decimal, so it would serve the purpose. The length of the rope is 240 plus 40 pi by 3. That is the answer for this particular part. Now what else is it asking for? Find the area of the hexagon. Now let me draw a triangle and then I'll relate what exactly do I mean by this. Why have I drawn it like this? And I have drawn a triangle like this. If this angle is, where it is, this angle is theta. So let me label, remove everything from here. Has served the purpose. So if I label the same color combination, this is orange and purple and blue. So this is orange and purple and blue, like this. Now if this thing is 60 degrees and this thing is 90 and the whole thing has to be 180, therefore this is 30, correct? So now let me take it over here. This thing angle is 30 degrees. This thing is 20 plus 20. This thing is 40. And if I label this thing as opposite and this is adjacent. So sine of 30 degrees is opposite over 40. Sine of 30 is half, that's opposite over 40, therefore opposite is 20. That's the first thing. Cosine of 30 is adjacent over 40. Cosine of 30 is root 3 over 2, that's adjacent over 40, therefore adjacent is 40 times root 3 over 2, that comes out to be 20 root 3. That is the next thing that I found. Now what do I need now? I need the diagram again. So let me draw the diagram on this side. And what else do I need? So now this diagram is just like this. Let me get this straight. This is the orange thing. This is the blue thing. And this is the purple thing. The same thing would be mirror image on this side, like this, and like this, and like this. So you have to be very, very careful. And this orange is again over here, and this orange would again be over here. Now look at this diagram. We are looking for area of this hexagon. I am thinking in terms of trapezium. These two sides are parallel. So AB is 40. And let me label this thing as G and H. F of G is that opposite side. F of G is this thing 20. And GH is again 40. And HC is again 20. And AG is 20 root 3. Got the idea? So area of trapezium is half sum of parallel sides. One side is 40, the other side is 20, 40, 20, which is 80, multiplied by the height, which is 20 root 3. 40 plus 80 is 120. 2 ones are 2 tens are 180 into 10, that is 1800 root 3. That is the answer for this part. So now what else do I need? This is the area of the trapezium. I hope I have not left out anything. There is also another trapezium. This is 1, this is 2. The other trapezium is 1800 root 3. Therefore, the total area is 3600 root 3. Now let me just double check my numbers. Sine of 30 is half, that opposite over 40. So therefore opposite is 20. Cosine of 30 is A over 40, that is 40 into root 3 over 2, 2 ones are 2 20s are, that's also done. So now this adjacent is the height and these two are parallel sides. This is 40, this is 40, this is 20, this is 20. 40 plus 20 is 120. So now let me get this straight. So this is not 18, a small eraser. This is, and this is 120, and this is 1200 root 3. This is 1200 root 3. Therefore, the correction is done. That is 2400 root 3. That is the answer for this one. Now, once this is done, find the area of the complete region enclosed by the rope. So now this trapezium is drawn. Let me complete the trapezium first. That is like this, and like this, and like this. This trapezium is all done. What else do I need? Now I need this sector, I need this sector, I need this thing. There are 6 of them. And I need this green rectangles like this one, and this one. So I need 6 rectangles and 6 sectors, and that would serve the purpose. So now this rectangle over here, if let me get this thing straightened out, it's not coming out. So let me just draw it properly. So therefore there are 6 rectangles. What about these rectangles? That would be 40. So this is 40, and this thing radius is 20. So 6 rectangles is 6 into 40 into 20. And there would be sectors. There would be 6 sectors. So that is like this, like this, like this, and like this. So there would be 6 sectors. This is 20, this is 20, this is pi by 3. So therefore 6 sectors, that is 6 into half r square, theta is pi by 3. So 4 into 2 is 8, 8 6 are 48. So that is 48 and 1 2 zeros. And similarly 6 into half into 400 into pi by 3. So therefore 2 1s are and 2 2s are, that's 200, that's 3 1s are and 3 2s are, that is 400 pi. That is the answer for this one. And the trapezium is already included. Therefore the total area is 2 trapeziums, which is 2400 root 3 plus 4800 plus 400 pi. So that is the answer in the exact form. And again, they have not written exact or inexact, but I'll prefer to write the answer in this form. So now that completes this particular paper in 2 parts. First 7 questions separate, and then the last 5 questions separate. Take care, stay tuned.